Okay, so we are on page 49 today, and we're going to look at some more completing the square problems. So you had some notes last week about how to complete the square. Remember, this is how we switch from standard form to vertex form. So we're going to take a look at a couple of these problems together. I want you to notice on page 49 that we have problems with a lead coefficient of 1, and we have problems with a lead coefficient that is not 1. As of right now, we don't know how to handle stuff that has a lead coefficient that's not 1. So problems like 3 and 4 and 6, we don't know how to handle right now. So we're going to take a look at 1, 2, and 5 together, and that's what we're going to focus on for today. Your homework for tonight will be the rest of the notes on page 48. So your notes left off here last week. Your homework for tonight will be the rest of the notes on page 48, okay? Which we'll talk about how to complete the square when our lead coefficient is not 1. So we're going to learn how to do that. We don't know how to do that just yet. So on page 49, we're going to take a look at 1, 2, and 5, since those all have a lead coefficient of 1. So completing the square is where I split that middle term and create a new C. And we saw some problems like this last week. So if I take a look at number 1, I'm going to split the middle term. So instead of 2x, cut it in half and I get 1x and 1x. Since it's positive 2x, I want plus 1x and plus 1x. And then I'm going to add in a new C, and we'll get to that in just a minute. My current C, negative 9, we're just going to stick back at the end. Our new C is always going to be our cut in half number squared. So in this case, 1 squared. So we're going to have a new C of 1. And then I've added 1 to this problem, which has changed it. To keep it the same, I'm going to then subtract that same number at the end. And again, we saw this last week. So this is more of a refresher than anything. And now my first 4 terms, this chunk right here, that's something that's going to factor really nicely. Since it's 4 terms, you can use grouping if you'd like, and I believe that's what I did in the video that you watched for homework last week. The GCF for my first group is x. That leaves me with x plus 1. The GCF for my second group would be 1, leaving me with x plus 1. The stuff in parentheses is the same. So that's my new GCF that I pull out. And I'm left with x plus 1. When you're completing the square, you should always get the same factor twice, because that allows us to write that factor squared, which is what we want for vertex form. And then finally, these 2 numbers at the end, it should always be 2 numbers at the end, your old C, and then subtracting that new C. Those will just combine like terms and throw them at the end here. So negative 9 minus 1 would be minus 10. So there's our function in vertex form. My vertex for this, it didn't ask us for this, but for this one we'll state it. My vertex for this would be negative 1, comma, negative 10. Questions on that first one? Okay, let's take a look at number 2. Same idea. I'm going to start by splitting that middle term. So I'm going to keep the x squared, and then 20x plus 20x cut in half would be 10x and 10x. So plus 10x plus 10x plus something. I'm going to have a new C. Here's my current C, 104. Just going to stick that at the end. And then whatever I add here, I'll be subtracting at the end. So now I've got this set up, so I just need to fill in the blanks. I'm going to fill in the blank with my cut in half number squared. 10 squared is 100. I'm going to put 100 in both the blanks. Now these first 4 terms, I can factor by grouping like we did here. GCF for my first group is x. That leaves me with x plus 10. GCF for my second group would be 10, positive 10. That leaves me with x plus 10. My stuff in parentheses is the same, so I pull that out as my new GCF. And left over, I have also x plus 10. Remember, when we're completing the square, I should expect to get the same factor twice because I want to be able to write it in vertex form, which would be something in parentheses with x squared. Since I've got two of them, I can write x plus 10 squared. And then don't forget to combine your like terms at the end. 104 minus 100 would be plus 4. So there's our vertex form. Questions for me so far? Questions? Okay. Let's look at one more together for today. So for number 5, I'm going to start by splitting this middle term in half. So we keep the x squared. Negative 9 cut in half is not a whole number, right? Because 9's odd. That's okay. So half of negative 9. Negative 9 cut in half would be negative 4.5. So I write this as negative 4.5x minus 4.5x. And then plus whatever our new c is. Our current c, we just scoot to the back. And then whatever we add here, we also subtract at the end. So my setup is exactly the same for number 5 as it was for number 1 and for number 2. Okay. Now to fill in the blank, I'm going to take my cut in half number and square it. You might need a calculator for this one. I'm about to get mine right now. That's fine. If you're squaring a decimal, you may need a calculator. That's okay. So I got 20.25, and I'm going to fill that into both blanks. And then these first 4 terms is what's going to give me this part in parentheses squared, right? The first 4 terms is what ends up giving me the squared portion. Now for this one, we haven't done a lot of factoring with decimals or fractions. So I want to point out a pattern that we see here with some of our other problems. Did you guys notice how in the squared portion here, it's x with the cut in half number? We see that? In our final vertex form, we have x plus 1, and our cut in half number was plus 1. Over here, we have x plus 10 in parentheses, and plus 10 was our cut in half number. Do we see that? Okay. There's a little shortcut we can take, especially if my cut in half number is not nice. Okay. What do you think is going to be in parentheses with x? Yeah, that cut in half number. So there's a little shortcut we can take here. It's going to be x minus 4.5 squared. When you're changing to vertex form by completing the square, in parentheses with x is going to be x with your cut in half number. Be careful with your signs. So this was x plus because it was positive 1 and positive 10. This is minus 4.5, so we want minus 4.5 here. And then combine your like terms at the end. So 20.25 negative 20.25 plus 12 would give us negative 8.25. And there's my vertex form. Questions for me? Okay. And you did do a couple completing the square practice problems with your work on Thursday. So this is just a refresher since we've had kind of a long weekend. For the rest of today, I have some more practice on completing the square for you. Some of this we're going to work on today, and some of it we're going to work on tomorrow. So when you get your paper, I want you to stick to the front side, okay? You only are working on the front side today. On the back, we've got lead coefficients that are not 1. So I want you only working on the front side for today. Again, your homework for tonight is going to be the notes over the rest of those completing the square problems on page 48. So for your homework tonight, you're going to take a look at how we approach those problems when the lead coefficient is not 1. And I don't think that we talked about that in Algebra 1. So that will be new for us. That's why we're only working on the front side for tonight. So on your paper, only the front side, you've got a problem in standard form. You've got some space to change it to vertex form. I want you to give me vertex form, and I want you to identify the y-intercept and the vertex. Remember, we see the y-intercept from standard form. We see the vertex from vertex form. And then the last piece I want you to give me, based on that lead coefficient, think about the shape of your graph, and tell me, is that vertex going to be a maximum or a minimum? Okay, so just the front side.